Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, up to now what we have covered is, in the previous two videos I have told you about the RC oscillator. The first RC oscillator that we studied was Wein bridge oscillator, and the second one was RC phase shift oscillator. And I told that the RC oscillators are audio frequency oscillator, that is, they are used to generate frequencies in the audio frequency range, which is actually low frequency. So now we will shift our attention on the LC oscillator. LC oscillators are radio frequency oscillator, high frequency oscillator. So they are used to generate frequencies almost above 500 megahertz. Now these LC oscillators basically use a tank circuit or a LC circuit. Okay, we know that LC circuit is called as a tank circuit. They use LC circuit in positive feedback configuration in order to generate oscillation. Why we need positive feedback? According to Bark-Hussein criteria, any oscillation can be sustained only if there is positive feedback. But that positive feedback here is applied by means of tank circuit, and that is why they are called as the LC oscillator. Okay, they can be used in signal generator, frequency mixer, tuner, sine wave generator, and RF modulator. These are certain application of LC oscillator. Now on your screen you can see that the LC oscillator general circuit is shown. At the top with op-amp we have constructed a inverting amplifier. This one is inverting amplifier, and at the bottom we have connected a feedback circuit by means of three impedances Z1, Z2 and Z3. So there are three impedances which are combinedly forming the feedback circuit, and that is called as a split tank. Now this inverting amplifier is providing a phase shift of 180 degree, but in Bark-Hussein criteria the loop gain should have a phase shift of 0 degree or 360 degree. That is why the split tank should also provide a phase shift of 180 degree, and then only this circuit can work. Okay, for 0 degree phase shift, the split tank as well as the inverting amplifier both must provide a phase shift of 180 degree, so that the net phase shift is 0 degree or 360 degree. Now let us see how does this split tank work. How does this provide a phase shift of 180 degree? So let us take Z1 and Z2 as two resistances. Suppose they are equal resistances, and we have a voltage, suppose V in. Okay, this voltage is suppose V2, V1, this is V2, this is ground. Okay, actually this terminal is not directly grounded, it is connected to this non-inverting terminal. Okay, and then it is grounded. So where it is connected? It is connected to the non-inverting terminal. We know that non-inverting terminal or any input terminal of op-amp does not have any current. The input current to the op-amp is always 0. If input current is 0, the current through both R must be same, because this terminal is connected to non-inverting terminal in which the current will be 0. So the current through both the resistances will be same. Now current from V1 will be V1 minus 0 by R, and current from the second resistance will be 0 minus V2 by R, which means V1 equal to minus V2. Or you can say V1 and V2 have phase shift of 180 degree, and that was my objective. Using the split tank circuit, I want to realize a phase shift of 180 degree. And how is that getting satisfied? Because the current through the middle terminal is 0, because it is connected to non-inverting terminal of the op-amp. Hence the current through both Z1 and Z2 will be identical. Okay, so we can provide a phase shift of 180 degree. Now what kind of circuit can be used in the split tank circuit? One example I have showed you. In this example I took both the resistances. We want a phase shift of 180 degree. Similarly, what you can do? You can use two capacitors. Similarly, you can use two inductors. So these three circuits can be used in the split tank circuit to provide 180 degree phase shift. Now coming back to the original circuit. When we come back to the original circuit, we have an inverting amplifier and we have a split tank. So what is the gain of inverting amplifier? The gain of inverting amplifier is actually minus RF by R1. Okay, that is minus RF by R1. That is the gain of inverting amplifier as we derived in the op-amp section. Okay, now what about the split tank? So let me draw the split tank again. The split tank is somewhat like this. Okay, this is Z1, this is Z2, right? Let me check the previous diagram. Yeah, Z1 and Z2. In middle there is ground. This voltage is V0, this is Vf. Now what I will say? I will say that the current through Z1 and Z2 will be identical. Both will be I. So how you will write the first I? V0 minus 0 by Z2, and the second current 0 minus Vf by Z1. So Vf is equal to minus V0 Z1 by Z2. That is your feedback voltage. So we know that the ratio of feedback voltage and output voltage is called as the feedback factor beta, which is minus Z1 by Z2, and the gain of amplifier is A. Now what about Bark-Hussein criteria? In Bark-Hussein criteria, A beta must be equal to 1. So RF by R1 into Z1 by Z2 must be 1. Okay, if it is 1, then what you can say? We can find the relation between RF and R1. RF equal to R1 Z2 by Z1. But what we need also, what we need is the relation between, or what you can say, we also need the oscillation frequency. So how you can find the oscillation frequency? For that you have to observe that this current I will flow in the loop. If I current is flowing in the loop, then I can apply KVL. I Z2 plus I Z1 plus I Z3 equal to 0. So what you can say? Z1 plus Z2 plus Z3 equal to 0. So based on Bark-Hussein criteria, we can find the value of the feedback resistance, and by equating the sum of the three impedances to 0, we can find the frequency of oscillation. Okay, so this condition is used to determine the frequency of oscillation of the LC oscillator. Okay. So remember how you find the frequency of oscillation by equating the sum of the impedances to 0. Okay. And how you find RF by using Bar-Hussein criteria. Now if the sum of three impedances is 0, all three cannot be inductor or capacitor, because then their sum can never be 0. We know that when we talk about impedances, inductor and capacitor cancel each other. So Z1, Z2, if both are capacitor, then Z3 must be the inductor. If Z1 and Z2 are capacitor, if Z1 and Z2 are inductor, then Z3 must be capacitor. Are you getting my point? Sum of three capacitances or inductances cannot be 0, but inductance and capacitance can cancel each other. That is why if you are using Z1 and Z2 as capacitor, Z3 must be the inductor. If Z1 and Z2 are inductor, Z3 must be the capacitor. So we designed two oscillators, one containing two inductor plus one capacitor, which is called as Hartley oscillator. Then the second one, two capacitor plus one inductor, it is called as Colpitt oscillator. Okay. So we designed two types of oscillator based on this LC oscillator theory. Okay. So let us start with our first oscillator, that is your Hartley oscillator. Now see, the circuit is same that we studied earlier, an inverting amplifier using R1 and RF, but now Z1, Z2, Z3 are not arbitrary, but they have been shown that we are using two inductors and one capacitor. So what about Z1? Z1 can be written as SL1. What about Z2? Z2 can be written as SL2. What about Z3? 1 by SC. Okay. So now we know the value of Z1, Z2, Z3 instead of keeping them as the arbitrary value. Okay. Now what I told is, by equating the sum of three impedances to 0, we can figure out the operating frequency or oscillation frequency. So SL1 plus SL2 plus 1 by SC equal to 0. If you go in frequency domain, S will be replaced by j omega. J omega L1 plus L2 plus 1 by j omega C. So j omega L1 plus L2 equal to minus 1 by j omega C. Now take j omega on the left hand side, is equal to minus 1 by L1 plus L2 into C. Now j square is minus 1. So we can say that omega is 1 by under root C multiplied by L1 plus L2, or the operating frequency is 1 by 2 pi under root C multiplied by L1 plus L2. So that is the operating frequency of your Hartley oscillator. So we write it also as 1 by 2 pi under root C into L equivalent. Now if you have magnetically coupled inductor, if the two inductors are magnetically coupled inductors, then the equivalent inductance is actually L1 plus L2 plus 2M. Okay. So equivalent inductance is L1 plus L2 if both are decoupled, but if both are coupled, then inductance is L1 plus L2 plus 2M. Then what I told is, I also told that RF by R1 should be equal to Z2 by Z1, which means RF is R1 into L2 by L1, because Z2 is SL2 and Z1 is SL1. So from here we can get the relation between RF and R1. Now we can also realize the same oscillator using BJT. So what I have done is, op amp was which kind of amplifier? we were using inverting amplifier. That is an amplifier which provides 180 degree phase shift. So if you want 180 degree phase shift in BJT, we can make use of common ammeter configuration. Common collector and common base provide 0 degree phase shift, but common ammeter configuration will provide 180 degree phase shift. So see this circuit. This is nothing but a common ammeter amplifier with self bias or voltage divider bias. Common ammeter amplifier with voltage divider biasing. Okay, so that is your amplifier implemented using BJT, and we are using the same type of split tank circuit. Okay, the same thing we can do in MOSFET. For MOSFET, if you need 180 degree phase shift, which kind of amplifier you will use? We will make use of common source amplifier. Okay, now what are the points that you need to remember? That it has variable frequency. How variable frequency? If you see, this capacitor is variable, and we know that the operating frequency is 1 by 2 pi under root C into L equivalent. So by varying the value of C, we can vary the value of operating frequency. Okay, the drawback is harmonic content is high. Harmonics, what are harmonics? Harmonics are sinusoidal components which have frequency multiple of the fundamental frequency. What is the fundamental frequency here? It is F0. That means we will not have a single signal, but we will have multiple components, and they will have frequency multiple of F0, and that is why its harmonic content will be very high. Okay, so that means it cannot generate a pure sine wave, it will have harmonics, so the waveform will be distorted. Okay, third, it has low frequency. Why low frequency? Because L equivalent is high. Inductor can never be very small value, so inductor is high, and that is why frequency is low. Secondly, it will also be bulky, because inductors always have large size, so the size of this oscillator will be bulky. Okay, so that is the point, some points that you have to remember about Hartley oscillator. Moving to the next one. The next type of oscillator is Colpit oscillator. Now see what we have done. We have used the same inverting op-amp, but now we are using two capacitors and one inductor in the split tank circuit. Earlier there were two inductor and one capacitor. Now we have two capacitor and one inductor. If you write the value of Z1, Z2 and Z3, Z1 is 1 by SC1, Z2 is 1 by SC2, Z3 is SL. Now when we want to find out the frequency of oscillation, then what we will do? We will make Z1 plus Z2 plus Z3 equal to 0. So 1 by SC1 plus 1 by SC2 plus SL equal to 0. If you replace it by j omega, 1 by j omega C1, 1 by j omega C2 plus j omega L equal to 0. So 1 by j omega, 1 by C1 plus 1 by C2 equal to minus j omega L. Now take this j omega on the right hand side. That means omega square L. So what will be omega? 1 by under root L. Now 1 by C1 plus 1 by C2 will be C1 plus C2 by C1 C2. Okay, that will be the case. Sorry, 1 by L. So actually it will be C1 C2 by C1 plus C2. That means you can also write as L into C equivalent, or the frequency will be 1 by 2 pi under root L into C equivalent, where C1 and C2 are in series. So C equivalent is actually C1 C2 by C1 plus C2. Okay. So in the previous Hartley oscillator, what we were getting? C multiplied by L equivalent. But in Colpit oscillator, what we are getting? L multiplied by C equivalent. What change I have done? I have used 2 capacitors and 1 inductor. Earlier we were using 1 capacitor and 2 inductor. Similar to the previous case, we can replace this inverting amplifier by a common emitter BJT amplifier. Okay, we can replace it by a common emitter BJT amplifier. So you can see this. This is a common emitter amplifier with voltage divider biasing. Okay. Similarly in MOSFET, what amplifier we will use? We will make use of common source amplifier. Okay. Now what is the advantage of this Colpit oscillator over Hartley oscillator? Okay. What is the main advantage? The main advantage is at high frequency, the reactance of capacitor, which is 1 by omega C, is very low. If reactance of capacitor is low, the high frequency signal will get a low reactance path or low impedance path. So what we can say? High frequency signal get low impedance path. In the feedback, the high frequency signal will have low impedance path, and hence at high frequency the response will be more sinusoidal. So that is the disadvantage of Hartley oscillator, was that it was unable to generate sinusoidal signal. The signal had harmonics and distortion, but here at high frequency the signal will be smoother and it will be more sinusoidal. Okay. It is also a variable frequency oscillator. How it is variable frequency? Here we are writing that operating frequency is 1 by 2 pi under root L into C equivalent. As you can see, inductance is variable, so we can vary the operating frequency of the circuit. Okay. It is used where wide range of frequency is required. Okay. Then basically it is mostly used where high and low temperature occur frequently. That means where the temperature variation is large, sometimes the temperature may be high, sometimes the temperature may be low, this type of oscillator is preferable. Okay. So that is what we are saying about this oscillator. The third oscillator in LC oscillator is called as the clap oscillator. So clap oscillator is nothing but modified version of this Colpit oscillator. Okay. How it is modified? That we are using a variable capacitor C3. Okay. So we have modified by adding a new capacitor C3 in order to improve the frequency stability. Okay. So by adding C3, we will later on understand what is frequency stability. So by adding C3, frequency stability is improved. Okay. So we just want to improve the frequency stability of the circuit, and that is why we are using C3. Okay. Now what is the operating frequency of this circuit? Is 1 by 2 pi under root L C3. Now what happens is C3 dominates C1 and C2. If C3 dominates C1 and C2, so that is, then what happens basically, operating frequency becomes independent of C1 and C2. So that is desirable. What I want actually is operating frequency should depend on lesser number of parameter so that the frequency almost remain same. But if it depends on more number of parameter, then what will happen? The frequency can change if any parameter varies. That is why in clap parameter we are using an additional capacitance that will dominate the earlier capacitors. Okay. The last oscillator we study is called as the crystal oscillator. Now earlier we were making use of tank circuit in order to generate the oscillation, but crystal oscillator uses mechanical vibrations. Okay, that is, we are not going with the electrical circuit, but we are going with mechanical vibration, and that is being used to generate electrical oscillation. Now what is the main reason behind going for crystal oscillator is high degree of frequency stability. What is meant by frequency stability actually? That with respect to change in environmental condition, the operating frequency of the system should not change. That is, no matter what happens, the frequency of the system should remain same as it is, and that is called as the frequency stability. Okay. So that is why crystal oscillators will be used in application where we need a constant frequency. As if you have studied microprocessor, there to generate the clock signal. To generate clock signal, we always make use of the crystal oscillator. Okay. Now, what is the basic principle of this crystal oscillator? So in crystal oscillator, what happens when mechanical strain means deformity is applied? When mechanical strain is applied, stress is developed. Always remember, strain is the reason for development of stress. Due to this development of stress, the electric dipoles become aligned and generate electric field and voltage. So that is what a crystal oscillator is based on. We call as piezoelectric effect. Piezoelectric effect means electricity or electric effect is generated when mechanical stress or pressure is applied. Piezo, by meaning of piezo, we mean to say pressure. So under mechanical pressure, electricity is generated, and that is called as the piezoelectric effect. Okay. So this crystal oscillator is always based on the piezoelectric effect. So as you can see, in crystal oscillator we have a piezoelectric material such as quartz. So what are the piezoelectric material which are commonly used or naturally occurring? Piezoelectric materials which naturally occur are two material, quartz and Rochelle salt. These two materials are commonly occurring piezoelectric material. So what we have done, between the plates of capacitor we have placed a piezoelectric material which also acts as a dielectric. So that is the construction of your crystal oscillator. And if you see from the outside, it will have two axes. One is the mechanical axis. Mechanical axis is where your pressure will be applied, and electrical axis where we can observe the voltage. So along electrical axis voltage will be produced, and along mechanical axis we will apply stress or strain. Now what we do is, we model this piezoelectric crystal by means of an equivalent electrical circuit. Okay, I want to represent it in terms of network analysis. So what I'll do, see the circuit. First we have RLC and then a capacitor in parallel to it. RLC, and suppose this is C0. Now how I am drawing this circuit? What does each parameter represent? R represents damping or internal losses, because when mechanical crystal will vibrate, the oscillation will be damped out due to internal losses. Then C is the stiffness, which is also equal to 1 by K. K is actually called as the spring constant. In any mechanical material, there is always a degree of stiffness, that is, it cannot be compressed or stretched without opposition, and that is called as the stiffness. And L represents mass of crystal. L represents the inertia or mass of the crystal, and C0 is actually the capacitance between anode and cathode, because I told you it is also working as a capacitor. The anode and cathode are two plates of the capacitor between which a dielectric is placed, so it is also working as capacitor, and capacitance between anode and cathode is given by C0. Okay, so RLC are not actual parameters, but they indicate certain physical phenomena inside the crystal. But C0 is actually the capacitance between anode and the cathode. Okay. Now since it is a second order circuit, it has two resonant frequencies. Okay. In second order circuit we will have two resonant frequencies. One in case of series resonance, that is due to RLC circuit, and the second one is due to parallel resonance, in which we will include the effect of C0. So what is the series resonance frequency? It is 1 by 2 pi under root LC. What about parallel? 1 by 2 pi under root L into C equivalent. What is the C equivalent? C into C0 by C plus C0, because in this circuit C and C0 will come in series. Okay, that is your parallel frequency. Now C equivalent is actually less than C. If it is less than C, it means the denominator is less in FP. So you can say FP is greater than Fs. So now if you plot the impedance of the circuit with respect to frequency, if we plot impedance, if I plot mod Z versus frequency, frequency is your F, then how does the curve look like? It looks like this. Okay, this first frequency is your Fs, series frequency, in which impedance is maximum. In parallel frequency, admittance is minimum or impedance is maximum. In series resonance, at resonance impedance is minimum. In parallel resonance, at resonance impedance is maximum. Here the behavior of circuit is capacitive, here it is inductive, and then again capacitive. Okay, so these are the two resonance frequency at which we can say that the crystal oscillates. Okay, and this parallel resonance is also called as your anti-resonance. Why anti-resonance? Because impedance is becoming maximum at this resonance frequency. Now, what are the features of crystal oscillator? It has fixed frequency. Now this frequency always lies between Fs and Fp. The frequency is fixed and it will lie between Fs and Fp. Okay, it is simplest RF oscillator because we have just taken a piezoelectric crystal. We don't have any circuit components. The frequency of oscillation, if we represent using F0, is inversely proportional to thickness of the crystal. Okay, F0 is inversely proportional to the thickness of crystal. Is it fine? It has large quality factor. It has large Q. Okay, and it can generate carrier wave in AM and FM. So that is also one application of the crystal oscillator. Now we have regularly been talking about frequency stability. What does it mean by frequency stability? It means that operating frequency should not change with environmental conditions. That is, no matter what are the external conditions or operating condition, the operating frequency must be same. For this we define a figure of merit. Figure of merit means a parameter by which we can judge the performance. Okay, figure of merit for any system means a parameter by which you can judge the merits and demerits of such a device, or you can judge the performance. So what is the figure of merit of this crystal? It is d theta by d omega. For any crystal it is d theta by d omega, where theta is phase angle of amplifier. Okay, now suppose we see for crystal oscillator at Fs minus the nature is capacitive, at Fs plus the nature is inductive. So what will be the phase for capacitive behavior? For capacitive behavior phase is almost minus 90. For inductive behavior phase is almost 90 degree. So what is FOM? Theta inductive minus theta capacitive upon frequency of inductive Fs plus and Fs minus. Now these two frequencies are very close. If they are very close, it will tend to infinity, or you can say highly stable circuit. So what I mean to say here is that if the variation of phase with frequency is very large, like this, if it is very large, the variation of phase, this is the variation of phase and this is the variation of frequency, then system will be highly frequency stable. That is, for small change in frequency, there must be large change in the phase of the system, and then you can say that the system is highly stable. So if we summarize, what we have to remember, in Hartley oscillator we have 2 inductor and 1 capacitor. So the frequency of oscillation is 1 by 2 pi under root C into L equivalent. In Colpit oscillator we have 2 capacitor and 1 inductor, so 1 by 2 pi under root L into C equivalent. In Clap oscillator, frequency is 1 by 2 pi under root L C3. So it makes it independent of C1 and C2. It is modified version of Colpit oscillator. And then if I summarize all the oscillator that we have studied, so first is RC phase shift. It can generate frequencies from 1 Hz to 10 megahertz. Okay. Then VN bridge. It can generate from 1 Hz to 1 megahertz. Okay. Then Colpit, 10 kilohertz to 100 megahertz. Hartley, same as Colpit, but Colpit is more stable at high frequency. Then Clap oscillator. Clap oscillator is also same. It is just the modified version of Colpit oscillator. So if you arrange in the order of stability, Hartley oscillator is least stable and Clap oscillator is most stable. So why we were moving from Hartley to Clap oscillator? So we were trying to increase the stability of the system. Okay. So remember this thing, and a vague idea of the range of frequency, so that if it is directly asked in objective question, you can mark the answer. So these are general type of oscillator, and in the next lecture we will see how to generate oscillator using positive feedback in op-amp, which is also called as the Schmidt trigger. That we will cover in the next video. Thank you.
I hope all of you have enjoyed the lecture that we were providing, and all of you learned something very, very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very, very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 50-50 with code Ankit ESE, it becomes 45-25. And 2-year subscription becomes 66,600. So the choice is yours, but take a longer duration subscription for more cost-effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.